Okay, cool. I think that we can officially get started. So, hello, all you lovely people. It's so nice to see you all here. I'm really pleased that you've chosen to come over to this session. So, to introduce myself, I am Steve, and I work at Microsoft. I work on the ASP.NET team, and I spend all my time working on this thing, Blazor. And fun fact for you all, Blazor started here at NDC Oslo. It was originally just a little demo in a conference presentation here 2 years ago, and the people said, we like that so much, you've got to do it. You've got to make that a real thing and turn that into an actual product. So we had no choice at all. We had to just go and do this thing, but you're all responsible. So in a way, I think we can say we are all the mummies and daddies of Blazor. We are, it's in all of our hearts. I think you'd agree, right? Or possibly you've never even heard of this thing at all. And if that's the case, I need to get a sense of that. So can you give me a show of hands if you've got any sense of what Blazor is? You've heard anything about, like, every single person. Cool, good. All right, so when I do this talk, I'm going to give you I'll do a little bit of introductory stuff because there may be some people who either haven't really seen it or they can't really remember it. But I know a lot of you will know the basics. So I'll go through the basics pretty quick, and then we'll start getting on to some slightly more advanced and newer stuff. So what is this thing anyway? Well, good chance you know, but just in case you don't, the basic situation with web development these days is that you've got some code that runs on a web server. Maybe it's in the cloud somewhere, which is your application logic, but it's not all of your application logic because you also need to make a user interface appear to your users. And they are in a web browser. So how do you make a UI appear in a web browser? Well, the traditional answer has been you use one of these things, a JavaScript framework. And you go about your day-to-day development life and you're happy and you make your UI. So that's all very well. But it's a bit limiting, really, isn't it, if the only way you can do a UI is using a JavaScript technology or something that compiles to JavaScript. And that got us thinking on the .NET team, wouldn't it be cool if we could use some of the new emerging technologies like WebAssembly, well, it was emerging 2 years ago, it's pretty well established now, to enable you to write your front-end web application with .NET inside the browser. And that is the original idea of Blazor. It was to build on the ability to run .NET on WebAssembly and enable you to build a rich user interface that runs in a purely standards-compliant way, no plugins inside your browser, and hopefully make you very productive. Okay, so let's just have a look at the basics of a Blazor web application, which I know a lot of you may have seen before, so we'll go through it pretty quick. So when you create a new project, whether you use Visual Studio in Windows, or whether you use the command line tool on Linux or Mac or on Windows, then when you first create it, it looks like this. So it's a pretty typical dashboardy kind of website, which has got a couple of different pages in it that we can do client-side navigation, and we can click a button to increment a counter. And behind all that is .NET code. So if we look over here in Visual Studio and we zoom in a bit, we can have a look and we'll see that we've got no JavaScript in our application. We've got C# files and Razor files. So what's a Razor file? Well, it's the new name for CSHTML when you're using it inside Blazor. And each one of those Razor files is a component. Blazor is a component-based UI framework, so you build your application out of lots of components. For example, the counter component. This is what we had just here when I was clicking this button. And if we look, we can see it uses a page directive to say that this is the component we should display when the user is on this URL. We have got some HTML markup, and we've got some C# code because we're able to run your C# in the browser now. So we've defined this current count, we're displaying the current count, and we've got a button that says when you click it, we're going to call a C# method, and it will increment the count. And similarly, if we switch over onto this fetch data page, you'll see again, we've got a page directive to say that it's what we display when we're on this URL. We are able to inject services from the dependency injection system. And here we're injecting an HTTP client, so we can make a request to the server. And if we scroll way, way, way down here, we can see that when this component is first initialized, it's going to make an HTTP request for some JSON data, which comes back asynchronously, and we're going to deserialize it as an array of weather forecast objects. And then, once we've got that, we can do this simple C# loop over those forecasts and produce the HTML necessary for that bit of UI. Okay, so pretty straightforward stuff. We're going to get on to building bigger and more interesting application in a few minutes. But before we get there, let's do a little bit of a warm-up and remind ourselves what the basic programming model in Blazor is. So let's make this page here, this fetch data page, a little bit more interactive. Let's say we look at the weather and we think, I don't really like that weather. I want to change it to something else. So let's make the weather editable, shall we? Let's say I want to be able to edit the temperature. Well, how can I do that? Well, I can do so basically using normal HTML. So I can say, instead of displaying the temperature C, I'm going to have an input type equals number, because it is a number, and then I'm going to tell Blazor to bind the value of that to the temperature in C. So we can now edit it. And we can do a couple more things too. So let's say, instead of the temperature in Fahrenheit being fixed to whatever the server said, we are going to compute it dynamically. So we're going to say it's the temperature C times 2 plus 30, because I hear that is approximately the formula for doing that. And then finally, let's display something else. Let's display some overall statistics about the weather for the entire week. So if you had to describe the weather throughout an entire week, what sort of statistic would you use? Well, like everybody, any normal person in the street, they say, what's the total temperature going to be this week? How many degrees will be happening altogether? So we'll say total temperature this I have to type it, week is going to be, we'll get the forecasts, and we are going to sum over all of the forecasts temperature C values, okay? And then we can say it's that many degrees in total this week. But one more thing we have to do. Before the forecast data has been loaded, it's going to be null. So I'm going to use the question mark operator to say, when we don't have that data, we're just going to have null there instead. Okay, so let's see if now we've got an editable weather page. It looks like we have. So I can click on these up and down buttons, and you'll see the temperature in F will go up as I do that. So does the total temperature. And if we make it really warm tomorrow, you'll see like the total temperature properly reacts to that. Okay, so there is some basic Blazor programming concepts. We've got page directives, we can inject services, we can display HTML, we can include C# expressions in our HTML, we can do C# control flow with loops, we can use bind to both display and read data from the user, we can put arbitrary C# code in, we can make requests to the server, and we can work with custom types. All that sort of typical Blazor programming experience. All right. So there's your basics of Blazor. I hope you're ready now to move on to something a little bit more interesting and advanced. And first, I want to get into how this stuff is actually working behind the scenes. So I've been telling you that we can run your .NET code in the browser, but how exactly does that work? I've been saying the word WebAssembly quite a lot, but what even is that, and what does it look like on the inside? So, to make your code run in the browser there, we're using a stack of 3 technologies. And the bottom layer in our cake here is WebAssembly. So WebAssembly is a bytecode format for the web, which has been supported in all the browsers for 2 years now. So that's all the desktop browsers and all the mobile browsers. They all support it. It's not a new or experimental thing. It's just been there for a long time by now. And the idea with WebAssembly is that you can take your code from whatever language you want to work in and compile it to WebAssembly. And it's the bytecode format that is designed for performance and simplicity, really. So it's going to run the same in all the browsers, and it should be able to get to within about a factor of 2 of running at native speed. That's WebAssembly itself. Okay? Now, in terms of how we run your .NET code, a reasonable person might guess at this stage that we've found some way of compiling .NET to WebAssembly. That's be a completely reasonable guess, but it's actually not true. That's not what we're doing at this stage, although it is something that we are working on doing at some point, well, some point fairly soon. But currently, what we're doing to run your code is we've taken a .NET runtime and we've compiled that to WebAssembly instead. So we can load this .NET runtime into the browser, and then that can load and execute normal .NET assemblies. And the particular runtime that we're using here is Mono. And if you're wondering why Mono, well, the answer is that Microsoft currently produces, ships, and supports 3 .NET runtimes. We've got .NET Core, .NET Framework, and Mono. And of those three, Mono is the one that's designed most around portability. So it was the one that was by far the most practical for us to compile and get running on WebAssembly. But in the long run, this doesn't even matter because, as you'll have seen with the .NET 5 announcements, this is all converging anyway. But for a long time, for now, you're going to see the word Mono showing up. Maybe you'll always see the word Mono. I don't know what the final branding is going to be. But it's not really going to matter very much in the long run. Anyway, the final layer in our technology cake is Blazor itself, and that is the UI programming model. So that's the thing that knows about what components are, the fact that components have parameters, they need to get re-rendered, they can be nested, all that kind of stuff that you've been seeing already. So let me actually prove to you that some of the claims I've just been making are actually true by showing you this actually happening inside the browser. So we've got our Blazor Basics thing here, and if I pop open the Browser Network tab and then I do a reload, then I'll zoom in a little bit, and what we'll see is this is all the stuff that we've sent down to the browser there. So we've sent the initial HTML page here, which contains a reference to this library, this tiny bit of Java, well, it's not tiny actually, this bit of JavaScript called blazor.webassembly.js, and that's the thing that knows how to load and start up the Mono WebAssembly runtime. So it loads a few more things, and then you'll see it's loading mono.wasm, and that is Mono itself, which has been compiled to WebAssembly. And then, into that, we can load regular .NET DLLs. So we've loaded the normal assembly for your application, which has been built by the normal C# compiler, no weird magic involved. And then we also load the various other dependencies that we've got to make your application actually load. Now, if you're wondering how big this thing actually is, let's try and measure that. So I'm going to disable my cache. So I'm pretending to be a completely fresh new user who's never seen this before. And we'll see that the total amount of network traffic involved in loading this thing is 2.3 megabytes by default. So that is, on one hand, that's great, because that's really small for a .NET runtime. Normally, .NET runtimes are like hundreds of megabytes. So we've done a lot of work to bring it down to 2.3 megs. But at the same time, it's also pretty large for a web page. So whether or not this is suitable for your use cases depends on what they are. For some sort of internal business application, that's probably completely fine. For public-facing applications, you've got more of a decision to make. We are working on bringing that down further as time goes on, but that's what we've got to now. And the other thing to bear in mind is that this is only a first-time thing. Of course, it's cached. So if I enable caching and do this again, you'll see that the total amount of network traffic transferred now, 15.5 kilobytes. So, you know, it really is just a first-time thing. OK, so what else can we say about this? What is this mono.wasm thing? What is on the inside of that file? It's WebAssembly bytecode, but what does that actually look like? Can we see it? Can we debug it? The answer is yes, we can see it and we can debug it, but it is not a very useful thing to do. But I'm just going to do it anyway. So let's just close these things because that's distracting. And we'll see that if we want to see the inside of Mono, we can look in our Sources tab in this WASM folder here, WebAssembly, and you'll see that it contains hundreds and hundreds and hundreds of these tiny little snippets of WebAssembly bytecode. Now, these aren't all separately fetched in different HTTP requests. That would be insane. This is just the browser giving you a sort of human-readable view of the inside of mono.wasm. And so it converts all the binary bytecode into this text-based format, and we can see all the different functions that have been compiled there. And if you look closely at it, you'll see that this bytecode format for WebAssembly is it's a stack-based virtual machine. It's all about putting stuff onto a stack, performing operations to mutate the stuff that's on the stack, and getting it back off. And it only operates on basic numeric types, and it's designed all around performance. But it's not very interesting or useful to be looking at your application at a bytecode level. If you really wanted to debug your app, you would want to see your C# source code, right? So how can we do that? Because there is no awareness of C# in the web browser. Well, what we've done is we've created a little debug server that runs in the background when you're in development mode. And your browser can connect to that, and it tells the browser what's going on inside Mono's runtime. And if you want to access it, you'll see we've got this debugging hotkey, Shift-Alt-D, or Shift-Command-D if you're on a Mac. So if I press Shift-Alt-D right now, you'll see it pops up another set of the browser dev tools. And these are the real browser dev tools. They are connected to our application. So to prove that, if I go to the Elements tab here and move this out here, then when I start hovering over stuff, you'll see that stuff gets highlighted because it really is the browser's actual dev tools there. And if we go on to the Sources tab, I can now expand File, and you'll start to see our actual application source code. So if you've seen this before, I can tell you we've got a few improvements that we've added to that recently. One of them is that we now show your application in its original hierarchical folder structure and not just one giant list of files as we did until a few weeks ago, so that's cool. Another thing I'll show you in a second, but first observe that yes, we can see our C# source code here, not just C#, we can also see our Razor code. And if I want to set a breakpoint, then that's absolutely going to work. So if I come back over here and then I navigate to the fetch data page, you'll see we've hit that breakpoint. So we're able to actually have a debugger for C# code running inside the browser tools. And another thing that we can do now that we couldn't do until a few weeks ago is we can put a breakpoint right in the middle of the rendering logic as well, if we want to. So if I go away from there and come back, you'll see we hit this breakpoint during the rendering logic, and better still, if you look down here, you'll see we can now start to inspect the shape of some of the .NET objects that are alive inside that runtime. So we've got this F variable here, which is of type weather forecast, and if we expand that, you'll see we can even see the properties on it. Now, this is not a complete production-ready debugging system. There's a lot of work left for us to do to make this really ready, as evidenced by the fact that although we can display strings and numbers, we don't even have a way to display date times just yet. But we're working on it. We're going to add, all the low-level primitives of .NET will become available so that you'll be able to properly debug your application inside the browser there. Okay. Right, so that's enough about what's going on behind the scenes there. We've looked at how mono.wasm gets loaded and what's inside that, and we've seen a little bit about debugging. But now, I want to build something bigger and more interesting. And using this other application, I'm going to be able to show you some of the newer things that we've just shipped in the last month or two. So I'm going to switch projects now. I'm going to switch over to this other thing, which I call Mission Control. So what's Mission Control? Well, as I've told you, my day job is being a developer on the ASP.NET Core team and working on Blazor. But I have this little side project that I do in the evenings and weekends, which is running a network of spies and secret agents who mostly operates around New York City. And so I've created this application here that lets me track where all my agents are and what their current missions are. Okay? So let's run it, and then we'll talk about how it works. So when it comes up, you'll see it looks kind of familiar because it's the same basic structure as the thing I showed you before. It's got a sidebar, which is sort of slidey in this case, and I can switch from home onto agents, and it's going to get a list of my agents from my backend data source there and display it. And I've deliberately made it look quite similar to the default project template so that it's easier for you to understand the structure, but we are going to add some more interesting things to it. Okay, so let's just see how does this agents page, just to remind ourselves what that sort of code looks like. Well, firstly, let's have a look at the overall solution structure. You'll see this time, instead of having just one project, I've now got three. And this is what you get when you use the Blazor hosted on ASP.NET Core project template. It gives you three projects. A client project, which is your client-side Blazor application that runs under WebAssembly inside the browser. It also gives you a server project, which is a regular server-side ASP.NET Core application. And that's got two jobs, really. The first job is to actually serve the client application to the browser. And the second job is to be a place where you can put your server-side API endpoints so that you can deal with things like interacting with a database, enforcing security rules, all that kind of thing. And then finally, we've got the last and best project, which is the shared project. And it's best because it can be used in both places. It's simply a regular net standard class library that's referenced by both client and server, which means if you ever need to exchange data between the two server and client worlds, as you always do, then you can guarantee that they've both got the same representation of the data. You're never going to have a situation where they're out of sync and one thinks that the data has different properties than the other. And we'll look at that a little bit more in a minute. But next, let's see how that agents page was implemented. So it will be very familiar to you. Just like the weather data page, it's got a page directive, it injects the HTTP client, and then down at the bottom, we do an HTTP request to get the list of agents. We don't have to define the agents class here, because that's in the shared project, so that the server knows how to send that data as well. Okay. Now, what about the styling of this thing? You may notice, if you're a keen observer of UX, that this is following the Google material design sort of styling. And the way I've done that is I've used a component library. One of the key design goals of Blazor is that it should be really easy for you to take a library of components to do common things like grids and tabs and all that kind of thing, and just use it in your application. And those libraries should be able to bring styling to you as well. And we also need to make it easy to create those libraries, and we'll get onto that in a minute. But right now, we're using one of those libraries, and let me show you how we can use it a little bit more. So I want to use my material design component library to improve this loading experience. Currently, it just says the word loading, but if I wanted to make it a little bit cooler, I could delete that loading thing there, and I'm going to use a material design linear progress bar. And since I won't say what the progress proportion is, it's just going to display a sort of indefinite spinner. So when I reload now, you'll see we get this cool little spinny effect going on as we appear there. So that's just to show you that we can use a component from a library. And we'll look more about how to create those libraries in a bit. Now, that's how the application is hosted on ASP.NET Core on the server. What about something a bit different? Authentication and authorization. Well, that's quite important for my application because obviously my list of agents is highly secret and I don't want it falling into enemy hands. But really, doing this allows me to demonstrate to you some features that we just shipped about 3 weeks ago in our Preview 6 release of Blazor. We've now got built-in infrastructure for dealing with authorization and authentication. First principle of security when you're doing client-side development is your security is not on the client, okay? All real access control has to happen on the server because anything you do on the client can be bypassed by anybody with just a basic awareness of browser dev tools. So the first thing we want to do is secure the access to our agents list in server-side code. And you can do that really easily. You've probably done this before if you've done any ASP.NET Core. So I'm going to go to my agents controller. This is the server-side endpoint that returns the data. You can see it's just hard-coded, but it could actually go to a database. And I'm going to use a feature that's been in there for years and years, probably longer than some of you have even been alive, called authorize. And that's just an attribute that tells the server you can only get to this data if you are authorized. And what does it mean to be authorized? Well, it depends how you've configured it. And in this case, I've configured it here to say, when it comes to authentication, I want to use JSON Web Tokens. Who's used JSON Web Tokens in an application before? Like, more than half of you. For the rest of you, a JSON Web Token is just a string. It's a string that says who you are and what roles you're in and anything else the server wants to say about you. And that string is then signed by the server. So the server knows that no one can tamper with it or make up their own claims about who they are. The server gives that string to the client, and then when the client wants to make a request later, it includes the string in the request. So the server can look at it and say, oh yeah, that's a valid signed string. I can parse that and see who you are, and then I can trust you. Okay, so now I've enforced that in the server. I'll recompile my application, and hopefully now, since I'm not logged in, I should not be able to get that list of agents anymore. So if I go to this list of agents, you'll see that it just stays stuck in this loading state forever. And in fact, if we look in the browser dev tools, you'll see the server replied 401 unauthorized, which makes sense because we didn't send any JSON Web Token with that request. Okay. So we'll deal with logging in a second, but first, let's think about the user experience for logged out users. Currently, the experience is this. It just gets stuck in loading. Now, that's not a very cool experience. It would be better if it tells you that you can't see it because you're not authorized and you have to log in. Wouldn't it be nice if we could do that in a really simple way? For example, if we could take the authorized attribute that we know and love from server-side programming and also use it in the client as well. Well, that's a feature that we've just added a few weeks ago. I can now say I want to add an attribute to agents component authorize. So now you'll only be able to see that if you're authorized as far as the client is concerned, and I'll talk about what that means in a minute. Okay, so now, when I go over onto this page, instead of getting the loading screen, I'll just get access denied, only logged in mission commanders may access this area. Now, believe it or not, that's not the default message. That's something I've customized, so it's really easy to customize how that looks, and you can put custom content in there. Okay, so we've got a better logged out experience now, but I want to deal with actual logging in. In fact, I want to show whether you're logged in or not up here in the top right of my page. And so where does that text come from today? Well, it's coming from logindisplay.razor, which is a little component. It's a very simple component, as you can see. It's just a bit of static text. So what I want to do is display different content depending on whether the user is logged in or not. And I can do that using another one of our newly shipped features, which is the built-in authorized view component. An authorized view gives you a context variable from which you can get information like the user's login name. So you can say, hello, whoever you are. And if the user's not logged in at all, they won't see anything. But I want to do slightly more than that. I want to display a whole different set of UI depending on whether you're logged in or not. So I'm going to dump in this big chunk of code, and you can see what it does is, if you are authorized, we'll display this icon and we'll say, hello, your name, and then we'll have one of my material design buttons, and it will say, when you click it, we're going to log you out, because if you're logged in, you probably want to be able to log out. And if you're not authorized, we'll display a button that just says login. And what does it mean to log in? Well, we're going to call a method on login dialog. Login dialog is a thing that I've added in my project here, and I'm using the ref keyword to get a reference to it so I can call public methods on it. So you click that button, it's going to tell the login dialog to log in. Okay, what's login dialog? Well, when you first see it, it might seem a little overwhelming, but don't be scared. It's not insane. It's, what is it? It's 50 lines of code, which VS currently believes is invalid, but I don't believe it's invalid. So I don't know what VS is talking about. We'll ignore it for a minute. I'm sure it will wake up in a second. There we go. It's happy now. Right. So what have we got in login dialog? Well, firstly, I'm using a material design dialog, and I've got a couple of text fields that you can enter a username and a password. And as for where that data goes, well, I've defined a class called login credentials, and I've got one of these. So if we look at that login credentials, you'll see it's pretty simple. It's just got a username and password, and kind of bizarrely an accept terms, but you'll see why I've added that in a few minutes. Okay? So we've got an editor for credentials. You can edit username and password, and there's a checkbox that lets you accept the terms. And then we've got a couple of buttons. One of them is the login button, and when you click it, we'll call submit credentials. And what does that do? Well, it takes the credentials that the user has entered, and it posts them to this endpoint on the server. And the server's going to reply with a login result, which may include a JSON Web Token, if it likes your password. And so if the token is null, we'll say your login failed. But if it's not null, then we'll store that token in our authentication state provider, which is another one of the things we've recently shipped. And that keeps track of whether the user is logged in or not and who they're logged in as. And then finally, we can just make the dialog go away. All right. So if this all works now, then when I come back here, I've got my login button. I can click on login, and my pretty dialog appears, and I can type in some credentials. If I enter bad credentials, the server will say no, and we'll get the message. But if we enter good credentials, and I'm not actually going to accept the terms. We'll deal with that in a minute. When I click login, the server will say, yep, here's a JSON Web Token for you. The client can parse that and get your username out, and then the UI changes to show me the agent screen. But it's still not displaying the list of agents. Why is that? Well, the server still says 401 unauthorized. Why does the server not like me even after I've logged in? Well, the answer is because even though I've got this token on the client, I'm still not sending it back to the server with the request. So that's the last thing I need to do. I'm going to get this token by injecting my token authentication state provider, and then from that, I can construct an authentication header. We'll get the token, and then we'll build an HTTP header that's got the name bearer and the value, well, it's got a value that comes from combining bearer and token. And I'm going to send that on my request to the server. So now, hopefully, it should be happy to return that agent's data to me. So if I reload now, then because I'm logged in, it will actually give me the data. And the other cool thing about these built-in components is they're all designed for interactive client-side use, so they update immediately. If I click on the log out button, it will instantly switch the rest of my application into the logged out mode. And if I click in login again and I enter my password again, then it will immediately switch me back to the login state. And of course, you can go further and have users in different roles and policies and all that kind of stuff. But that's the core set of authentication features. All right, let's move on, and we'll see some other new stuff that we recently shipped. And I'm going to show you now validation. That's obviously a very important feature for many kinds of realistic applications, and we don't have any of it in this one right now. So right now, if I click on if I bring up this login form, I can submit the form even if it's completely blank and even if I haven't accepted the terms. Now, the server won't accept my login because obviously it's not a good password, but I don't think this is very good. I think we shouldn't even be allowed to submit the form to the server unless it's valid. So let's add some validation rules. And validation is a little bit like authorization in the sense that you often need to do it in most cases, you will want to enforce your validation rules on the server, not just on the client. If those validation rules really matter to you in terms of what data gets stored, you can't trust the client to honor any client-side validation rules, so you do need to do server-side validation. And that is very straightforward if you're using ASP.NET Core on the server and has been for many years. So one simple way you can do it is you can use these kinds of data annotations attributes. So now on my login credentials, I'm saying that things are required, I've got some length constraints, and I'm defining some error messages. Okay? Now that is technically all I have to do to make my server start enforcing those rules. Because I'm using an API controller on the server, by default, it will honor data annotations rules. So let's see if that works. Now if I try to submit a blank form, that's not what I expected to happen. Did I not do that? Let's try building this all again. I'm going to submit a blank form. And OK, that is what I expected to happen. So now I appear to get no response at all from the server. So why did the server not respond? Well, actually, it did respond. It responded 400 bad request. And it actually gave a list of the reasons why it was a bad request and what the validation errors were. But I'm not really interested in that. What I am interested in is now also enforcing the same validation rules with client-side validation. And hopefully, I don't have to define my rules in more than one place because they're all shared on a single class that's shared between the server and the client. So how do we do client-side validation with Blazor? Well, we can use some relatively new things that came out, I think, in Preview 5. And the first thing I'm going to use is something called an edit form. Okay? An edit form is something you can wrap around part of your UI, and what it does is it keeps track of an edit operation that is in progress. So it knows what fields are being edited, whether they've been modified, and what validation messages apply to them at any given time. And if you want it to do validation, then you need to tell it what object it is that we're going to be validating when the form is submitted. And you also have to tell it how to validate that object. And in this case, because I'm using data annotations rules, I'm going to add a data annotations validator into my form there. And that's more or less all you have to do, but I want to do a little bit more. Firstly, if there are errors, I think it would be polite to actually display them on the screen in some way. So I'm going to add a validation summary down here at the bottom of my form. And finally, if the form is invalid, I don't want you to be able to submit it to the server anymore. So I'm going to change this button so it doesn't invoke the server directly, but instead, what I'm going to do is I'm going to say, for the form itself, if there's a valid submission, as far as client-side validation is concerned, then we're willing to submit it to the server. Right. Let's see if this actually does the validation now. So I'm going to click login, and I'll try to submit a blank form, and what happens is it does, in fact, run the validation on the client there. So we know which fields are required. We know that the terms must be accepted. That's a good start, but I think it's a little ugly right now. I don't like having this list down here. I'd like to have different messages in different places. So what I'm going to do is get rid of the validation summary, and instead, I'm going to use another built-in thing called validation message. And so we say what it is that we want to validate. I want the username's message to appear up there, and then below that, I'll display any message for password, and below that, I'll display any message that we've got for accept terms. And let's see if that looks a little bit better now. So now if I submit a blank form, you'll see I get different messages in different places. You'll see that the fields can get highlighted. That's just control through CSS. And as I start typing stuff in, you'll see that they get marked as valid and the messages disappear. And as I toggle this box, obviously, the message for that will appear or disappear. And if finally it's valid, I'll be allowed to log in. Okay? So it's cool. It's client-side validation, and it's designed to interoperate very easily with what you're doing on the server. Okay. Now, last set of things that I'm going to show you inside the Mission Controller application is component libraries and static content. The ability to have static content in external projects and packages is a new feature that we just shipped in Preview 6, and it makes it easier to build libraries of components. So why am I talking about this? Well, so far, I've been using that material design component library, which is all very well, but someone's got to create these libraries in the first place. So how could we create our own component library and make it reusable? Well, what I want to do is I kind of like my site at the moment, but I'm not really a big fan of lists. I think it would be way cooler if instead of a list, we were to display an interactive 3D map showing where all the agents were around the city. But, you know, interactive 3D maps will probably take quite a while to implement. So what I want to do is use an existing JavaScript one that I can find and turn that into a Blazor component library so that that 3D map can be used in any Blazor application very easily. Right, now you'll see in my solution here, I've got a project already that I've created called PinMap Library. And it doesn't really have anything in it yet, apart from a www.root folder. And inside there, I've got a JavaScript file called pinmap.js. So that's the library that I want to use. It's actually a wrapper again around yet another library. But I want to make this available to anyone who consumes this project or package. So how can I do that? Do I need to create some custom build steps to copy this JavaScript file into your project or something? No, I don't actually have to do anything anymore. Because of this new feature, if you have a class library that uses the Razor SDK, then by default, anything from the www folder will become available to the thing that consumes it. So to consume one of these bits of static content, you just need to know about the URL conventions. So here, to consume that PinMap library, you can see that I've got a script tag that uses this special format, _content, and then the name of the project or package that contains the content, and then the path within that content to the thing that I want to use. So that's all it takes for the person who uses your library to use the static content from inside it. Okay, so that's a good start, but I want to make an actual Blazor component here for this map. So I'm going to make a new item, and I'll choose Razor component, and I will call it pinmap.razor. And what should we put inside pinmap.razor? Well, it would be nice if, yeah, here we go, great. So I would like to put a little bit of HTML inside there to get started with. So here, it's pretty simple. I've just got a div. And the first thing I want to do is check that when I use this map, it actually shows up in the UI. So I'm going to go back to my agents page, and I'm going to say, I don't want to have this HTML table anymore. I'm going to delete that completely, and instead, I want to use this pin map. So I'm going to type pin map, and you'll see I get immediately prompted to use this library, this component from my library. And the first thing to notice is that Blazor components are actual .NET classes. So they've got, as well as a class name, they've got a namespace. And you can reference them through their fully qualified name if you want to. But if you don't want to, then what you can do is add a using statement. So I can say using pinmap library, and then when I try to add the tag down here, you'll see I now get prompted not just with the fully qualified name, but also with the shortened name because of my using statement there. All right, so let's see if this does actually show up in the UI. When I reload, it now says to do render map. Good, and we've still got that agents text, which I want to get rid of. So let's lose that. And then I'll go back to my pin map, and I want to actually interact with the JavaScript library now. So we're going to do a little bit of JavaScript interop to turn this div into an actual map. So what I'm going to do is I'm going to start by injecting a service that lets me make JavaScript interop calls, the JavaScript runtime. And then using that, I can make a call. I'm going to say, when this component gets rendered, I want to make a call to JavaScript to a function in JavaScript called pinmap.createOrUpdate. And that function needs me to pass an actual element instance to it so that it knows where to put the map. So I need to pass this div into the JavaScript. How can I get a reference to this div in some way? Well, I can do so using the ref directive attribute. I can say ref for this equals map lm. That's just giving a name to it. And then I'll define a field where that stuff can go. There we go. And now this is all valid code. So we can refer to our map lm here, and that will be the element that gets passed to JavaScript. OK, so let's see if this actually makes the pin map display in my UI. I'll come back and I'll hit reload, and we'll see. Do we get the actual map? And the answer is yes, we do. We do get this Mapbox map, and we can see this whole downtown Manhattan area, and we can scroll around. And that's all very cool. But I want to not just show an empty map, but rather I want to show where my agents are on the map. And the way it works with this particular library is that it wants you to put these map pin elements inside it. And that defines where the pin goes with its longitude and latitude and whatever markup you want to show up when you click on that pin. But I don't want to just display a single map pin. I want to display lots of map pins, one for each of my agents. So I'm going to say this component takes a parameter, which is an enumerable of agents. And using that enumerable, I can do a for each loop to display a map pin for each of them. So I'm going to loop over all the data, and for each one, I'll use their longitude and latitude, and I'll display their name and their mission inside the caption. Okay, last thing to do is I need to actually pass this data property here into my pin map. So I need to make Visual Studio wake up. Let's try that again. Data, and then I can pass the agents into it, and hopefully that will render all of the elements for the pins. Let's try it. I'll reload again, and now hopefully we'll see lots of little red spots corresponding to each of my agents. So I can see, for example, here on Broadway, I've got Tim, who's, I can't remember why I asked him to get a part in a Broadway show, but I'm sure there's an important reason for that. And then we can have a look down here maybe at this pier, and we can see we've got someone intercepting enemy shipments. And yeah, so I'm pretty happy as a spy master that all my agents are doing useful stuff across the city now. But the more important point is that we can make these components, put them into libraries, and make them easy to consume and reuse. OK. Right then, let's move on to look at the broader world now, because I've only shown you one of many possible ways of using Blazor. There's much, much more to this. So far, all I've shown you is that we can take Blazor and run it on WebAssembly inside your browser and have it interact with the DOM directly inside the browser. That's what we call client-side Blazor. But this architecture is really flexible. And the fact that we've got this separation between how your components render and how they tell the DOM to update means that we can run it in different ways. For example, we can take the Blazor part of your application, the .NET part, and if you wanted, you can run that in the cloud on a server that's running somewhere remotely. And then, when it wants to update someone's UI, it can do that by pushing updates over a WebSocket SignalR connection so that the browser knows how to update. And that's what we call server-side Blazor, and that is going to be shipping with ASP.NET Core later, ASP.NET Core 3 later this year. So let me give you a little demo of that, and then we'll talk about how the pros and cons line up. So I'm not going to do it with the agents thing anymore. I'm going to show you a slightly different application now. This one's called Car Buyer, and I'll show you how it looks, and then we'll talk about some of the implementation details and what it's doing behind the scenes. So what this is, it's the sort of thing that you could use to buy a car, believe it or not. You could maybe use it at home on your own, but more likely you go into a car showroom and some person comes out with an iPad and they tap all the buttons and they persuade you to spend a lot more money than you were going to spend before. So it works like this. You go, OK, I probably like the look of this 8 system here. What engine shall I put on? I'll probably put the most powerful engine on. I'll go next from there. What color? I like the look of red. I'll put the massive alloys on it. And yeah, everyone loves sunroofs and self-parking. That sounds really fancy. Definitely want some of that. And then you think, OK, we'll go on from there. Next, how am I going to pay for this? Oh, well, that's very expensive. So I think I'm probably going to need a loan. So, $4,000 a month. We better change that repayment period. Maybe a bit more. Maybe a bit more still. OK, still pretty expensive, but maybe we can tolerate this now. And then finally, we're going to move on and we get the delivery details and stuff. So What's the point of showing that? Well, the point really is to look at how this is working behind the scenes and what's going on. So the code for our application here is this project here, carbuyer.server-side. And this is a regular server-side ASP.NET Core application, which is hosting my server-side Blazor. But I haven't actually got any components in here. For some bizarre reason that you'll understand in a few minutes, I've decided to factor out all my components into this other library called carbuyer.core, which is just a class library that contains a bunch of components for things like choosing delivery and choosing options and stuff like that. So normally you wouldn't do that. It would be strange to factor stuff out into a project, but it just goes to show that you can if you want to, and also I have a good reason that you'll see in a few minutes. As for how this is working inside the browser, this is a very lightweight way of running your Blazor application. We don't have to download Mono WebAssembly anymore. We don't have to fetch any of your .NET assemblies. If we look at the Network tab, you'll see that what we do fetch is now just a small number of things. And it's kind of difficult on this screen, but we'll zoom in. And you'll see that we're fetching just the HTML, CSS, some images, and that's it, apart from one more thing, which is we're opening this SignalR connection to this endpoint on the server called _Blazor. And that's where all the interactivity is happening. So when the page starts up, it opens this connection and says, I'm ready. And when the user performs any actions, we send a message to the server to tell them what they've done, and the server replies to describe how the UI should be updated. If you want to see that, you can look at the actual binary messages that are getting sent. So if I clear that out, and then I make some change, like I click on Next, you'll see that various binary messages get sent. These messages are for things like, there was a click event on a particular element within the render tree, and the server gets that, and it says, OK, I'll re-render the application, I'll compute the diff against its previous state, and I'll send a minimal description of what UI updates are needed to bring the UI up to date. And each of those messages is generally pretty small. It's usually measured in the tens or hundreds of bytes, because this is a very efficient, compact transport format. And that is how, every time I do anything here, the browser is being given instructions to update. Now, another cool thing about rendering your application on the server, about running your application on the server, is that we can very easily enable server-side pre-rendering. And what that means is, when the user first goes to your page, they don't have to wait for the WebSocket connection to be established before we can build the initial UI. What we can do is have the server do the initial render on the server and send the initial HTML, just as traditional plain old HTML that the browser can render without even running any script. So to prove that's happening, if I display the page source, you'll see it's not just a script tag, it's actually all the HTML for the initial UI there. And that means your application is easy to be crawled by search engines, which is great for search engine optimization. Now, pre-rendering can be done with client-side Blazor applications as well, but it's much easier if your application is already running on the server anyway. Okay, so that is server-side Blazor, and mainly I've just given you a list of pros for that. I've told you it's more lightweight, which is great. But what are the real full set of pros and cons to this thing? Well, on the plus side, yes, it's like a thin client situation. This is going to run really fast, even on very low-end devices, because they don't really have to download anything significant at all. They're just basically displaying a remote view of your application, so it's very lightweight. Also, because your code runs on the server now, it's not running on WebAssembly, it's running on full .NET Core on the server, and you have access to literally anything that .NET Core can do when it's running on a server, which is a lot of stuff. And then finally, you may be able to make your architecture simpler this way. So what do I mean by that? I mean, normally, when you're doing data access for a client-side application, you have to do it by making HTTP requests to some endpoint on the server, which then queries the database on your behalf, serializes it all as JSON, and sends that back. But with server-side Blazor, you don't even need to do most of that. Your code is already running on the server. There's no need to have special API endpoints. If you want to talk to a database, you can just talk to a database, like directly. You can go through a repository pattern if you want to, but there's no need to be serializing stuff and making API endpoints. So it just simplifies your architecture significantly. However, there's the cons as well. There are some real drawbacks to this model, so you have to balance this and decide what's best for you. The first con is, because this is running truly on the server, there's no way you're making this thing run offline. Every interaction is happening on the server. Another thing is latency. And this is a basic problem with physics. The basic problem is that, unfortunately, the speed of light is really, really slow, and it's so distressing that light is so slow that we can't do anything about it. The basic reality of it is that if your server is 100 milliseconds away in speed of light time, then you've got at least a 200 millisecond round trip, so there will be latency, basic physics. Finally, in terms of the fact that this code is running on the server means you're now paying for that CPU time. Whereas with the client-side model, each user brings their own CPU to execute your code. So it's up to you to decide which of those is the right fit for you. But that's not the full range of options. There are, in fact, more options still for a Blazor application. So let's think about the ways that applications can be deployed today. You can imagine there's a spectrum. With at one extreme end, there's the web with HTML and CSS and JavaScript, and it runs in your browsers. And at the other end, there's native applications that run on people's desktops for all the different operating systems. Which parts of that spectrum can we target with Blazor? Well, I've just shown you server-side Blazor there, and that's at the extreme end of server-side of web there, because every single thing is happening on the server, and we are even sending the initial HTML as being pre-rendered. So that's a very web-centric way of doing development. But with Blazor, you've got more options. So you've already seen that we can run Blazor client-side, and in fact, we can make our application on the client even work offline. So let me show you. I've got Carbuyer here that runs on the server, but I've also got another one, carbuyer.client-side, which I'll set as my startup project. And again, I don't have any components in here because I'm actually using the exact same set of components from carbuyer.core, just to show you that we can run the same code in two different environments without having to change the code. So if I now run that, you'll see we're now running the same application, to the same interactivity, no code changes, but it's now running client-side. And because this is a client-side application, we can even make it work offline. So I've already added the relevant service worker, which means that I can go over here and tell my browser that I want it to be in offline mode. And normally, web pages don't work when you're offline. But because this one has got my service worker, when I hit reload, what happens is it just shows up and it works, and it's still fully interactive. So we've now got our .NET application running inside a browser with full support for being offline. Okay, very good. But can we get any further towards a desktop application? Well, we can. What if instead of running it inside people's browsers, we want it to have its own application window and be installable into the operating system? Well, that brings us to the idea of a progressive web application, or a PWA. And any web application that can run offline can be a PWA. So I can make my Carbuyer application there installable into the user's operating system. And in fact, that's what I've already done. So if I, what am I doing? Right, so if I go to my start menu here and I look, you'll see I've got Carbuyer on my start menu right there. So if I click it, what comes up? The same application, but now it's not apparently inside a browser, it's now inside its own window, and it's installable, it's got its own start menu entry, etc. So that's the whole idea of a PWA. And we can target that too. Very good. But what else could we do? Is there some way that we could go even further with that? Well, what if we didn't want to run on WebAssembly? The PWA does run on WebAssembly because PWAs are purely web technologies. What if we wanted to do the same desktop installable application, but now we want it to run on .NET Core, just regular native code, not under WebAssembly at all? Well, that brings us to Electron. Electron is a way of running HTML-based application that's installable, and we've set up a way of connecting it to a regular .NET Core process. Now, this is not a product we're shipping right now, but is a sample that we've published that you can try out yourself. So let's have a go at doing that. And if we look in the third folder here, you'll see I've got carbuyer.electron. And again, it has the same reference to carbuyer.core because, again, it's the same components running without any code changes. And if I run that, then what we'll see is an Electron window pops up. And again, the same application works, same interactivity, but now we've got all the features of Electron. For example, all the ways it integrates into the operating system, all the ways that it deals with managing updates over time. And of course, now we're not running on WebAssembly at all. So that takes us really, really far down this spectrum to being a desktop application. So you probably think, that's pretty cool. That's really flexible. That's one programming model that can operate in a whole range of different scenarios. But do you think that we could push it any further? Like, is there any way that we could push this like right into the infrared part of the spectrum here and get even more desktop-like than we already have? Well, what would that even mean? Well, so far, all of our rendering has been based on HTML and CSS. What if we wanted a Blazor application that renders using something not HTML and CSS? Is that even possible? Well, it is, and I'm going to show you. But first, I'm going to caution you. This is not something that we have any plans around productizing, OK? This is purely a tech demo that I'm showing you that the architecture of Blazor is flexible enough for you to create your own renderer for Blazor that can target different kinds of rendering technologies. So let's give an example of how we can have a Blazor application that renders to something that's not even HTML. So I'm going to go to another project that I've got right here. And I wonder if from the name you can guess how this is going to work. It's called Blutter. And when I run this, what's going to come up is a Flutter application. So what's Flutter? Well, Flutter is a cross-platform UI technology. Flutter applications can run on Windows, on Mac, on Linux, on Android, and on iOS. And by default, they have this kind of Android styling, but you can make them look like iOS or anything else that you create the renderer for. And so what I've got here is I've got this counter that counts your clicks on a button. I've got this to-do list, and I can type stuff, and it adds stuff into a list. And then, I can do all the other stuff you'd expect. For example, scrolling. I can mark things as done. I can show this little slidey sidebar thing, and so on. Now, a Flutter application is usually built with the Dart programming language, but I did not build it with Dart. Can you guess what I built it with? Yes, of course you can guess. I built it with Blazor and .NET Core. So, how does the code for my application look? Well, here is the main layout for my application, and you will notice that it is not HTML. There's no HTML in here. I cannot use HTML even if I wanted to because there's no browser. What I can use instead are all these different Flutter widgets. So I've got a scaffold. That's the overall layout for the application. I've got an app bar with a title. I've got a drawer that appears on the side. I've got a tab bar and some tab bar views. And I've also got some custom components of my own. For example, counter. And if we go over there, you'll see it looks pretty familiar. Although we're not using HTML now, we've still got a button, and when you press it, it's going to call .NET code. And so just like we did with the counter in the web, we're able to update this count and display that in the middle of our UI. And similarly, we could go and have a look at this to-do list here. And it might seem a little bit like, what on earth is all this stuff? Well, this is how Flutter deals with styling. We've got things like column and row and flexible and things like that. And inside there, to display that list, you'll see I'm able to just use normal C# for each loop because it's the normal Blazor programming model here, and I can display my to-do list, my to-do entry. And inside the to-do entry, well, that's just got a checkbox and text. And of course, I can update the code for my application if I wanted. For example, let's say whenever you check on these boxes, I want to draw a line through the text to show that it's done. So I can use the line through feature of text in Flutter to say I want to display a line through if the item is done. If it's done. OK, good. And then I'll click restart for my application. And now, when I add stuff, then when I click on this button, you'll see the line through appears, and when I unclick it, it goes away. And this is a proper .NET Core application. I can even use things like the debugger in Visual Studio. So if I set a breakpoint right there and pop up my application one more time, then when I click on this count button, you will see we, of course, hit the breakpoint, and we can inspect the state of the application, and so on. So the point of me showing you all this stuff is just to say that this is a really flexible architecture. And following the same programming model, we can enable you to target an enormous range of different kinds of applications. And you can pick whatever you think is the best point on the spectrum for whatever kind of application you're building. And in a lot of cases, you can reuse your code in your components across different UI technologies. So that is all I'm going to have time to show you. There is a lot more that you can go and learn about Blazor if you want to. Tons and tons of features, which I don't have time to show you. If you want to learn more about them, then I would recommend that you go to blazor.net, where you'll find the instructions for getting started and the links to the documentation. And if you want the code and the slides from this talk, it's already published. You can go to that short URL there, which will take you to a repo on GitHub, and you can get access to that stuff. So that's all we've got time for. I hope that's been useful to you. I hope you remember to evaluate the session on your way out, and I hope that you really enjoy the rest of the conference.